Future trend. 1. Sustainability evolution, carbon negative revolution. Looking ahead to 2025 to 2040, sustainability will undergo a revolutionary transformation from carbon neutral goals to carbon negative achievements that generate significant revenue streams while solving global environmental challenges. This represents the most dramatic shift in agricultural environmental management in human history. By 2030, leading dairy farms will transition from carbon neutral to carbon negative operations, actively removing more greenhouse gases from the atmosphere than they produce while generating substantial additional revenue from environmental services. This transformation will position dairy farming as essential climate infrastructure rather than an environmental cost center. Carbon credit premiums will reach $30 to $80 per hectare annually from verified carbon sequestration, creating new profit centers that can represent 20 to 40% of total farm revenue. These aren't theoretical projections. Pilot programs are already demonstrating the economic potential of carbon farming approaches. Methane capture networks will create regional biogas cooperatives converting farm waste into renewable energy for grid supply, generating additional revenue while solving waste management challenges. These cooperative approaches will enable smaller farms to participate in renewable energy markets that would otherwise be inaccessible. Soil carbon markets will reward regenerative grazing systems that sequester 3 to 10 tons CO2 equivalent per hectare per year, transforming pasture management from cost center to profit center. Advanced soil monitoring will provide real-time carbon measurement, enabling precise management and verification. Blockchain verification systems will provide immutable carbon footprint tracking, enabling premium pricing for verified low-carbon dairy products, creating market differentiation that rewards environmental stewardship through consumer choice and willingness to pay premiums. Next-generation emission reduction technologies will revolutionize production efficiency. Seaweed supplementation will reduce methane emissions by 60 to 80%, while actually improving milk composition and animal health, demonstrating how environmental solutions can simultaneously improve productivity. Precision grazing systems will use AI to optimize both production and carbon sequestration through sophisticated rotational management that maximizes soil carbon storage while maintaining or improving animal performance. These systems will integrate satellite monitoring, soil sensors, and animal tracking for real-time optimization. Atmospheric water harvesting will reduce groundwater dependency by 40 to 70% through solar-powered systems that literally extract water from air, eliminating drought vulnerability while reducing environmental impact and operating costs. Living machine wastewater treatment will use engineered wetlands to produce clean water, renewable energy, and valuable biomass from dairy waste streams, creating multiple value streams from materials previously considered waste. Circular economy mastery will achieve new levels of resource efficiency and environmental benefit. Zero waste certification will become industry standard, requiring 95% waste stream conversion to valuable outputs, fundamentally changing how dairy operations approach resource management. Local resource loops will integrate dairy operations with urban agriculture, creating circular economy systems where dairy waste feeds city farms, urban food processing returns nutrients to farms, and regional resource cycling reduces transportation costs and environmental impact. Biodiversity credits will provide payment for ecosystem services as farms become wildlife corridors and pollinator sanctuaries, generating revenue for habitat creation while supporting regional ecosystem health and resilience. Climate adaptation infrastructure will become standard as farms designed for extreme weather and changing conditions. Storm-proof facilities will protect operations from increasing weather volatility, while heat-resistant genetics will maintain productivity under rising temperatures. Drought-resilient infrastructure will enable production continuity during extended dry periods, while flood management systems will capture and store excess water for dry period use, creating resilience against climate extremes. Seasonal flexibility will enable production systems to adapt to changing precipitation patterns and growing seasons, maintaining productivity while working with rather than against changing environmental conditions. Advanced environmental monitoring will provide real-time ecosystem assessment and management optimization. Satellite monitoring will track farm-level environmental performance, while IoT sensor networks will provide continuous soil, water, and air quality monitoring. Ecosystem modeling will predict environmental impacts and optimize management decisions for maximum environmental benefit while maintaining economic viability and production goals. Regenerative certification programs will provide third-party verification of positive environmental impact, enabling premium market positioning and access to sustainability-focused consumer segments and B2B customers. Off-grid energy solutions will become standard as farms achieve energy independence through renewable generation and storage systems. Solar installations will exceed farm energy needs, enabling grid sales and additional revenue generation. Wind energy integration will provide complementary renewable generation, while battery storage systems will enable 24/7 renewable energy use and grid services revenue generation. Biogas systems will convert organic waste to renewable energy while producing valuable soil amendments, creating multiple revenue streams from materials previously considered disposal costs. Innovation in carbon capture and storage will enable direct atmospheric CO2 removal through enhanced weathering, biochar production, and advanced composting systems that permanently sequester atmospheric carbon. Precision application of carbon sequestering amendments will optimize soil carbon storage while improving soil health and productivity, demonstrating how environmental benefits can enhance rather than compromise production. Advanced composting systems will produce high-value soil amendments while sequestering carbon and reducing methane emissions from organic waste decomposition. Partnership networks will enable small and medium farms to participate in environmental markets through cooperative approaches that achieve scale economies and shared expertise. Technical service providers will enable farms to access carbon markets and environmental programs without requiring extensive internal expertise. Environmental finance mechanisms will provide funding for sustainability investments through carbon credit advances, environmental impact bonds, and sustainability-linked financing that reduces capital costs for environmental improvements. Policy integration will align environmental regulations with market incentives, creating regulatory frameworks that reward environmental stewardship while maintaining production competitiveness and economic viability. International coordination will create global standards for agricultural carbon measurement and trading, enabling participation in international carbon markets and climate finance mechanisms. Consumer integration will drive market demand for carbon-negative products through labeling, certification, and marketing programs that enable consumers to support climate solutions through purchasing decisions. Corporate sustainability commitments will create B2B market demand for carbon-negative dairy products as companies seek supply chain emissions reductions to meet net zero commitments. Educational partnerships will build public understanding and support for agriculture's role in climate solutions, creating political and social support for policies and programs that reward environmental stewardship. Research and development will continue advancing carbon-negative technologies through university partnerships, government research programs, and private sector innovation that accelerates technology development and adoption. The economic transformation will fundamentally change farm business models from production-focused to ecosystem services-focused enterprises that generate revenue from multiple environmental outputs while maintaining high-quality food production. Key insight: by 2035, sustainability will have transformed from cost center to primary profit driver, with environmental services generating 20 to 40% of farm revenue. This transformation will position dairy farming as essential climate infrastructure while creating economic incentives that align environmental stewardship with financial success. The most successful operations will be those that embrace this transformation early and build comprehensive environmental service capabilities alongside excellent food production.